Chapter 3 ASP.NET Web API 101. It's easier to plot a course once you've seen the map. Now that we've established the context around why web APIs are important for modern networked applications, in this chapter we'll take a first look at ASP.NET Web API. ASP.NET Web API and the new HTTP programming model offer different capabilities for both building and consuming web APIs. First, we'll explore some of the core web API goals and the capabilities that support them. We'll then see how those capabilities are exposed to your code in ASP.NET Web API by looking at its programming model. What better way to examine that than by looking at the code provided by the Visual Studio Web API project template. Finally, we'll go beyond the default template code and construct our first Hello World Web API. Core scenarios. Unlike many technologies, ASP.NET Web API has a very well documented and ACHs. Cycle history. Some is recorded on Codeplex. From the beginning, the development team made the decision to be as transparent as possible so that the product could be influenced by the community of experts who would ultimately use it to build real SYS. TEMS. I've distilled all that history down to the core goals that ASP.NET was created to address. First, class HTTP programming. Symmetric client and server programming experience. Flexible support for different formats. No more coding with angle brackets. Unit testability. Multiple hosting options. Now, while these are key goals, they by no means represent an exhaustive list of all that the framework enables. ASP.NET Web API brings together the best of Windows COM. Muni-Cation Foundation WCF, with its infinitely extensible architecture, client support, and flexible hosting model, and ASP.NET MVC, with its support for convention over configuration, improved testability, and advanced features such as model binding and validation. As we'll begin to explore in this chapter, the result is a framework that is approachable for getting started, and easily customizable as your needs evolve. First, class HTTP programming. When you are building modern web APIs, especially for simpler clients such as mobile devices, success of that API is often related to its expressiveness. And the expressiveness of a web API depends on how well it uses HTTP as an application protocol. Using HTTP as an application protocol goes far beyond simply handling HTTP requests and producing HTTP responses. It means that the behavior of both the application and the underlying framework is controlled by HTTP control flow and data elements rather than by some additional data that is merely incidentally transmitted via HTTP. For example, consider the following SOAP request used to communicate with a WCF service. Host http://localhost/greetingservice.svc http:/1.1 content type text/xml charset equals UTF-8 SOAP action hello world. Content length 154. In this example, the client issues a request to the server to obtain a friendly greeting message. As you can see, the request is being sent via HTTP. However, this is really where the association with HTTP stops. Rather than using HTTP methods sometimes called verbs to communicate the nature of the action requested of the service, the AP approach shown here sends all requests using the same HTTP method post and wraps the application-specific details in both the HTTP request body and the custom SOAP-ACTION header. As you might expect, we see the same pattern repeated on the response produced by the service. http:/1.1200 OK content length 984 content type text/XML. Charset equals UTF-8 date Tuesday, April 26, 2011 012253 GMT. As in the case of the request message, the protocol elements used to control the apply. Cation, that is, the way that the client and server applications understand one another, have been pulled out of the HTTP elements and placed inside the XML bodies of the request and response, respectively. In this approach, HTTP is not being used to express the application protocol, but rather as a simple transport for a different application protocol, so, in this case. And while this can be a good thing for scenarios where a single service needs to communicate with similar clients across lots of different protocols, it can be problematic when the need is to communicate with lots of very different clients across a single protocol. These kinds of problems are illustrated perfectly in the case of web APIs, where the diversity of not only clients, but also of the communication infrastructure between clients and services, e.g., the Internet, is large and constantly changing. In this world, clients and services should be optimized not for protocol independence but rather for creating a first-class experience around a common application protocol. In the case of applications that communicate via the web, that protocol is HTTP. At its core, ASP.NET Web API is built around a small set of HTTP primitive objects. The two most notable of these are HTTP request message and HTTP response message. The purpose of these objects is to provide a strongly typed view of an actual HTTP message. For example, consider the following HTTP request message. Get http://localhost 50650/API/greeting http://1.1 host localhost 50650 accept application/JSON if none match 1. Assuming that this request was received by an ASP.NET Web API service, we can access and manipulate the various elements of this request using code similar to the following in a Web API controller class. Var request equals this dot request. Var requested URI equals request dot request URI. Var requested host equals request dot headers dot host. Var accept headers equals request dot headers dot accept. Var conditional value equals request dot headers dot if none match. This strongly typed model provides the correct level of abstraction over HTTP, empowering the developer to work directly with an HTTP request or response while freeing her from having to deal with lower-level issues such as raw message parsing or generation. 1. The catalog of public media types is maintained by the IANA. Symmetric client and server programming experience. One of the most appealing aspects of ASP.NET Web APIs being built around this HTTP-focused object library is that the library can be used not only on the server but also in client applications that are built using the .NET framework. This means that the HTTP request shown here can be created with the same HTTP programming model classes that are ultimately used to work with the request inside of a web API. As shown later in this chapter. As you will see in Chapter 10, there is a lot more to the HTTP programming model than simply manipulating the various data elements of requests and responses. Features like message handlers and content negotiation are built directly into the HTTP program. Main models so that you can take advantage of them on both the client and the server to deliver sophisticated client-server interactions while simultaneously reusing as much of your code as possible. Flexible support for different formats. Content negotiation will be talked about in much more depth in Chapter 13, but at a high level. It is the process whereby a client and server work together to determine the right format to use when exchanging representations over HTTP. There are several different approaches and techniques for performing content negotiation, and by default, ASP.NET Web API supports the server-driven approach using the HTTP accept header to let clients choose between XML and JSON. If no accept header is specified, ASP.NET Web API will return JSON by default though. Like most aspects of the framework, this default behavior can be changed. For example, consider the following request to an ASP.NET Web API service. Get http://localhost 50650/API/greeting http://1.1. Because this request contains no accept header to provide the server with the desired format, the server will return JSON. We can change this behavior by adding an accept header to our request and specifying the correct media type identifier for XML1. Get http://localhost 50650/API/greeting http://1.1 accept application/XML. No more coding with angle brackets. As the .NET framework has matured, one of the ever-growing complaints from developers has been related to the amount of XML configuration required to enable seemingly basic or even default scenarios. Even worse, because configuration controlled things such as which types should be loaded at runtime, configuration changes could introduce errors into a system that would not be caught by the compiler, but only at runtime. One of the biggest examples of this complaint can be found in ASP.NET Web API's predecessor, WCF. And while WCF itself has improved in the amount of configuration it requires, the ASP.NET Web API team went a totally different direction by introducing an entirely code-based configuration mode. ASP.NET Web API configuration will be discussed at length in Chapter 11. Unit testability as techniques such as test-driven development (TDD) and behavior-driven development (BDD) have become more popular. There has been a proportional increase in frustration with many of the popular service and web frameworks over their use of static context objects, sealed types, and deep inheritance trees. These techniques make unit testing challenging in that objects become difficult to create and initialize in isolation from the underlying runtime. They also are very hard to substitute with a fake instance for better testing isolation. For example, ASP.NET relies heavily on the HTTP context object, while WCF similarly relies on operation context or web operation context depending on the type of service. The fundamental problem with static context objects like these is that they are set up by and rely on their respective frameworks' runtimes. As a result, testing a service that was developed using these context objects requires actually starting a service host and running the service. And while this technique is generally acceptable for integration-style tests, it is unsuitable for a development style such as TDD, which relies on being able to run smaller unit tests very quickly. One of the goals in ASP.NET Web API is to provide much improved support for these kinds of development styles. And there are two characteristics of the framework that accomplish this goal. First, ASP.NET Web API has the same programming model as the MVC framework. This enables it to take advantage of the testability work that was done a few years ago, including abstractions to avoid having to use static context objects and wrappers so that fake instances can be supplied to unit tests. Second, remember that ASP.NET Web API is built around the HTTP programming model. The objects in this model are effectively simple data structures that can be created, configured, passed to an action method as a parameter, and analyzed when returned. This enables unit tests to be authored in a very clean, focused manner. As ASP.NET Web API has evolved, testing has remained a focus area for the team, as evidenced by the HTTP request context class in Web API 2. Testability will be discussed at greater length in Chapter 17. Multiple hosting options. Despite some of its lesser qualities, one of the greatest attributes of WCF was its ability to self-host, that is, its ability to run in any process. For example, a Windows service, a console application, or Internet Information Services IIS. In fact, this kind of hosting flexibility made its limitations in unit testing almost bearable, almost. When consolidating WCF Web API with ASP.NET to form ASP.NET Web API, the team wanted to keep this self-hosting ability, and so ASP.NET Web API services, like WCF services, can run in whatever process you choose. We'll look at hosting in much greater depth in Chapter 11. Getting started.